So the first question is asking, what is the absolute value? And notice parent function. So that means no transformations. I've not moved it. Where is that starting point? So for this one, that is just going to be y is equal to the absolute value of x. So notice that there's nothing on the outside, there's nothing in front, there's nothing inside. So no transformations have been applied. So what does the absolute value represent? So you'll notice that I provided a hint where I have the absolute value of -3 is +3, and then the absolute value of 3 is 3, and I say both are 3 away. So hopefully that helps you remember that the absolute value is all about distance from 0. So you can always draw a picture if it helps. So I'm just going to draw a little number line right here. So notice that both of these are a distance of 3 away from 0. So that is all about absolute value. Distances are always positive, so absolute value is always positive. What shape does an absolute value make? Hopefully you remember this one. It makes a V. Notice absolute value. So V is a nice easy trick to help you remember that absolute value makes a V. So I'm going to switch over to Desmos and we can explore each one of these individually. All right, here is our first. Let's take a look at the friendly one, which is H. So here I'm just going to move the H. And what do you notice when H is positive? How is it moving this graph? And then what happens if H is negative? What is it doing to this graph? How is it moving it? So here, absolute value, when H is positive, it's moving it to the right. And when H is negative, it's moving it to the left. All right, let's take a look at the next value. Let's look at the K and see what happens with this one in Desmos. All right, so K, if I make it positive, interesting. And then if K, it becomes negative. In Hopefully you saw when K was positive, it shifted the graph up, and when K was negative, it shifted it down. And some of the ways that I remember that are because K is on the outside of these absolute values, it's taking this entire graph and then moving it up or down. So maybe that can help you. Let's do the next one, which is going to be this letter A in the front. Let's see what happens. And notice you also have a plus or minus sign. So that is going to be a little tricky. So we're just going to do both of these transformations together. All right, here is our parent function. So A, notice if it's larger than 1, what do you notice is happening to my absolute value? Ooh, it's getting very tall. It's kind of getting stretched toward upward. So when A is bigger than 1, so 1.2, 2, 2.5, 3, this graph is getting stretched taller and taller and taller. So what we like to say is this graph, anything greater than 1, the graph is getting vertically stretched and it becomes narrow. So you'll see I even draw a picture. So here's 1. So let's see what happens. Oh, interesting. What do you see? As I get a smaller and smaller decimal, what's happening to this graph? What did you see? So if the fraction is less than 1, we probably saw a shrink or the graph became really wide. That we like to call a vertical compression. So it kind of gets smushed, it gets shrunk, vertical compression or shrink. So the last part is having you look at this positive or negative. All right, so here's the original parent function. So here's those decimals. See how it flattens the graph, it compresses it. But then when it becomes negative, ooh, look, the whole graph, all those values are now negative. So it flipped the graph And look, it's flipping and it's stretching. It's doing two things at once. So if it's positive, nothing's going to happen to the graph. It kind of stays, it'll just become a stretch, it'll get taller, anything like that. But if it's negative, be really careful because it will reflect along the x axis. So I always like to say, because it's exterior flips on the x-axis. So that could be a way to help you remember. This one is a good one because it has all the information that we're looking for. So it says identify the transformations. So first, I want you to graph the original parent function. That helps me see how it's moved. So over here on this graph, the original parent function kind of looks something like this. I've got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And then remember, the absolute value turns it positive. So -1 goes to +1. So that's where you start to see that change on this side. So here's -2 becomes positive. So now, hopefully, we can see how it moved. So here was the original vertex. And now it's moved all the way here. So let's talk about that. How did that move? So I can see that it went to the left by 7. Looks like it moved down by 2. And that's it. That is how you identify transformation. So graph the original and take a closer look. All right, where is my new vertex? How do I know where that's located? Hopefully you saw it's at -7 and -2. Well, I can see that vertex has a low point, so it's a minimum. And then my x-intercepts, where does my graph cross the x-axis? So I'm going to color those in and be sure you've listed those as points. So I've got one at -9, 0, and one at -5, 0. And the last one is the y-intercept. So where did it cross the y-axis? And that hopefully was located at 0 and +5. All right, on this one, it says, where is the vertex of the graph? So vertex is my keyword. So I highly recommend graphing this in Desmos. So that's what I did in blue. You can see how I've graphed it. So hopefully you can see my new vertex is simply located at -3 and +6. Okay, on this one, I'm just going to give you a couple of hints. One of my hints is to obviously check some of these in Desmos, and you can kind of do a quick comparison. But if it takes too long to put all of these in Desmos and then check your work, try to use some of your knowledge of transformations. For example, here on number 6, I can see a negative. Okay, so in that case, which one of these graphs has been flipped? So here, try to remember what that +4 and that +9 do. Hopefully you remembered it shifted the graph up. So for that one, take a closer look and see which of those graphs have moved up 4 versus up 9. And then here, I can also see this -4 and that 9. So hopefully that's moved my graphs to the right. And that's for both of them. They both moved right. So take a closer look and see if that helps you with the matching. All right, on this one, we're just identifying transformations. That's it. No graphing. So yes, if you would like, you can check your answers in Desmos. You also have a word bank, so you can even use that to help you. So here on number 8, I can see a +2 is on the outside. So it's taking everything and it's going to double. So my numbers are going to get very large. So that is going to be our vertical stretch of 2. All my numbers got really large. I can see a 17 on the inside of the absolute value. So here's what I can do if I'm unsure. I see right 17 and up 17. Well, since it's on the inside of my absolute values, that tells me it's going to shift to the right. And then the last one I see is a +12 on the outside. side. So I have to think about what that's going to do. Should move it up 12. So hopefully you can start to see some of the patterns here. This next one's a little tricky because I have four transformations, four different colors. Okay, well, the first one, I'm showing a negative on the exterior. So hopefully you've caught on. That's a flip on the x-axis. I even drew a picture. I see a fraction in the very front. So what that is going to do is take all of my answers, all my numbers that I'm plugging in, and it's gonna divide everything by 9. So all my numbers are gonna get really, really small. So when that happens, that's where I'm gonna start to see that compression or that shrink by 1/9. Everything's getting divided by 9. And then I can also see, oh, it's tricky. It looks like a positive 18, but don't forget, it's that tricky minus minus. But again, always check Desmos if that helps you. And then hopefully down by 2. All right, this last one we're going to do together. So this one is asking you about domain and range. So first thing I'm going to do is I'm going to graph that picture in Desmos, and then I'm going to take a closer look at the domain and range. Okay, here is that equation in Desmos. So here I can see that I've got a vertex right down here at -12, -8. I can plug in anything I want into this absolute value. Notice I can plug in, oh, here's my x-intercept. I can plug in negative x's. So here's all these points. Notice I can plug any x value. I can plug in negative numbers. I'm still negative, but notice I can still plug any number in that I want. So since I can plug in any x value that I want, I will have a domain of all real numbers. So again, I can plug in negatives, zeros, positive fractions, whatever you name it. So I can see that I have all these y values up here. I have positive 10, positive 11, but notice I keep having these low y values. Yep, 3, I can have 2. But look what happens when I get to the vertex. My graph stops at -8. And then look, all these y values go right back up. But it looks like I can have -8 and everything above that. But my range will be everything bigger or equal to -8.